Welcome to Lesson 2, and welcome back to our AI Foundations series. In Lesson 1, we talked about why vibe coding isn't enough if you actually want AI to live inside real systems. We introduced the 5 guardrails: tests, linting, types, logging, and architecture, and we saw how they turn AI from a chatbot toy into a reliable teammate. In this lesson, we're going to answer a different question. How does real work actually flow when humans and AI build together? The answer is a simple but powerful rhythm we call the PIV loop: plan to implement to validate. You'll see how this loop sits on top of your project docs, your README, CLOB file, and task lists, and how every feature becomes a series of small, safe steps instead of one giant, risky prompt. By the end of this video, I want you to be able to look at any change in your codebase and say, I know exactly what the plan is, what the AI should implement, and how we're going to validate it. All right, let's jump in and walk through the PIV loop. In Lesson 1, we talked about the difference between vibe coding and real full-stack engineering with AI, and we introduced the 5 guardrails: tests, linting and style, type checks, logging, and architecture. In this lesson, I want to show you how work actually flows when you build with AI inside a real project. This poster is the whole story in one picture. At the top, we plan. On the right, we implement with help from an AI assistant. On the left, we validate with our guardrails. And then we loop, over and over. Before we dive in, there's one important nuance. When I say plan, there are really 2 layers of planning. There's the big strategic plan for the whole project, the things you capture in files like readme.md, claude.md, tasks.md, architecture docs, and even external sources connected via MCP. That's the brain of the system. And then there's the small tactical plan for each PIV loop, for this one tiny change, what exactly are we doing plan. The big plan feeds PIV loops with tasks and constraints. The PIV plan is what we do right before we write code and validate it. And when a PIV loop teaches us something new, we can go back and update the big plan. In this lesson, we're mostly talking about that inner PIV plan, but always remember, it lives inside a larger project plan. By the end of this lesson, I want you to think of AI coding as a series of small PIV loops, not giant, risky, one-shot prompts. And later in the series, this is the same loop we'll teach our AI agents to follow inside your full-stack foundations repo. Most people use AI like this: generate my whole backend, create the entire React app, build the full feature for me. That's the Big Bang approach. It feels efficient until something breaks. Then you're stuck with a huge block of code you didn't really design, and debugging becomes a nightmare. The PIV loop is the opposite. Instead of build everything, we say, let's build one small, well-defined step at a time, and prove it works before we move on. That's what this loop is about. Small scope, fast feedback, continuous learning for you, and eventually for AI agents too. Let's start with the plan phase at the top. This is where you slow down just a little so everything else can move faster. Remember, our 2 layers. The project level plan lives in things like readme.md, claude.md, tasks.md, and architecture docs. It says what we're building overall and which patterns and constraints we care about. The PIV plan is local. For this one loop, what exactly are we doing? In the PIV plan step, you answer questions like these. 1. What am I actually trying to change? 2. Which lane am I in, front end or back end for this loop? 3. How will I know when I'm done? What will I see or what checks will pass? You can see that in the poster. On one side, we have the front end lane, React plus TypeScript. On the other side, we have the back end lane, Python plus Fast API. Sometimes your loop touches both, but most of the time, you pick one lane per PIV to keep things focused. A good PIV plan is small and concrete. For example, backend lane, add get/workspaces endpoint, plus tests. You also choose which files are in play. On the back end, this router file, this service file, this test file. And you are guided by the big plan. You might read Claude.md to see conventions for endpoints. You might look at tasks.md to pick the next slice of a feature. You might scan the README for how to run tests and tools. Finally, you define done. Done means tests X and Y pass. The endpoint returns JSON in this shape, and there are logs for success and failure. Once you've answered those, then you're ready to bring in the AI for the implement step. Now we're in the implement phase. This is where most people start, but in the PIV loop, we deliberately arrive here second, after planning. In this step, you write a structured prompt for your AI assistant. Tell it exactly what to change and when it's allowed to work. Keep the scope small enough so that you can fully understand the diff. A good implement step sounds like, here's the existing fast API router and tests. Add a get/workspace endpoint using the same patterns. Only edit router.py and test workspaces API.py. Keep linting, tests, and types clean. Or on the front end, here's the feature folder and an example list component. Create workspace list.tsx using the same patterns with mock data for now. Add or update tests in workspace list.tsx. The key idea, you are the lead developer. The AI is your very fast junior. It can write boilerplate, suggest refactors, and generate tests much faster than you could type them. But you're still the one who accepts or rejects its work. When the AI gives you code, you don't just use it blindly. You review it, you integrate it into the repo, and then you move to the third stage, validate. Now we hit the validate phase. This is where we ask, did this change actually do what we wanted? And did it avoid breaking everything else? The image shows tests running on one screen, UI or API checks on another, and logs being inspected. In a real project, validate includes things like running back-end tests with Purist, running front-end tests with your test runner, running linters and type checkers, opening the UI, clicking the new button or screen, and confirming it behaves the way you planned, checking logs to see what's happening under the hood. Now, here's the important part. You already met the 5 guardrails in Lesson 1. In this series, validate is where they all come together. When we say validate, we're not just saying, it seems to work. We're asking, tests, did our unit and integration tests pass after this change? Linting and style. Does the new code pass our linters and formatting rules, or is the AI leaving little landmines? Type checks. Did MyPy or TypeScript or Pydantic accept the new shapes and signatures, or are there mismatches? Logging. When we hit this feature, do the logs tell a clear story? Are we seeing any errors or suspicious states? Architecture. Did we keep the change inside the right feature slice and layer, or did we smear logic all over the place? So, in a healthy PIV loop, validate literally means run the tests. Run the linters and type checks. Glance at the logs if something feels off. Make sure we didn't break our architecture. If all of that is green, this PIV loop is done. If anything is red or broken, that's not failure. That's feedback. We either adjust the code ourselves or run another small AI-assisted implement step to fix the failure. And then we validate again. Once everything is green and the behavior matches our plan, we commit the change and move on. Some of that feedback may also cause us to update the big plan. Maybe we split a task in tasks.md. Maybe we add a new convention to Claude.md. Maybe we note a refactor we want to schedule later. That's the inner loop teaching the outer plan. So how do you build something bigger than a small endpoint or a single component? You chain PIV loops. Look at this image. You can see PIV1, PIV2, PIV3 linked together. PIV1, backend API example. Add tasks API under /workspaces /ID/tasks with tests. PIV2, front-end UI example. a tasks list component that calls that endpoint and renders the tasks. PIV 3, integration/glue example. Wire the new UI into navigation and add an end-to-end test. You're not trying to build the entire tasks feature in one massive step. You're building it via 3 or 4 small validated loops, each with its own plan, implement, and validate. This gives you clarity. You always know what you're working on right now. Safety. Every loop ends with guardrails. Momentum. You're constantly finishing small shippable pieces. And here's where AI shines. When you feed the AI smaller, well-defined PIV tasks, it performs much better than when you ask it to build a giant feature from scratch. This is also exactly how we'll want AI agents to work later. Many small PIVs, not one giant do-everything request. From this point on in the series, we're going to treat the PIV loop as our basic unit of work. In the Backend Foundations module, we'll run backend-focused PIVs, adding endpoints, wiring database models, enhancing logging. In the Front-End Foundations module, we'll run front-end-focused PIVs, building components, hooks, data fetching, error handling. Later, we'll chain PIVs together to build full-stack features, and eventually to drive agentic workflows on top of this stack. Every time you see me building something, you can ask, what was the project-level plan this came from? What was the PIV plan here? What did the AI help implement? How did we validate it with our 5 guardrails? Did this loop teach us anything that should update the big plan? If you internalize that rhythm, you'll be able to use AI in any stack without losing control of your project. Let's recap Lesson 2. The PIV loop is planned to implement to validate. We use it to keep AI coding small, safe, and repeatable. There are 2 levels of planning. A project-level plan in docs like README, Claude, and tasks. A PIV-level plan for each tiny change. We pick a lane per loop, front-end or back-end. We let the AI help with implementation, but we always validate using our 5 guardrails. Tests, linting and style, type checks, logging, and architecture. We chain PIV loops to build bigger full-stack features and, eventually, agentic workflows. Here's your homework for this lesson. 1. Pick one real change you want to make in a project. It can be tiny. Add a new API endpoint, or render an extra field in the UI. 2. Write down a mini PIV plan. Which lane, front-end or back-end? Which files will be involved? What does done mean in terms of behavior and guardrails? 3. Then try to implement it with AI help, and really go through a deliberate validate step afterward. Run tests. Run linters and type checks. Actually open the UI or hit the endpoint. Check logs if something fails. 4. At times, you may ask if this loop reveals anything you should add or change in your project-level plan. Do you need to update a task? Add a convention to your Claude.md? Capture a lesson in your README? Even if you don't complete it perfectly, just feeling this plan to implement to validate rhythm once will make everything in the next modules click faster. In the next lesson, we're going to zoom out to the modern full-stack model and see how front-end, back-end, database, and infrastructure all fit together with these guardrails. Thanks for watching Lesson 2. When you're ready, I'll see you in Lesson 3, the modern full-stack and AI PIV loops. Make sure you subscribe to our channel so you definitely don't miss even one lesson in this series. We will have at least 20 lessons to teach you to build AI foundations that can serve starters for any of your agentic AI applications. Applications that are rock solid and can be trusted. Also, hit that like button so YouTube will make this series available to more people interested in building real agentic AI applications. Thanks, and we certainly appreciate your support.